Radeanu is Wales' largest resort, uniquely situated between the Great and Little Orme peninsulas with two wonderful shores. The focus of our trip was essentially the photonics industry. There is a strong semiconductor industry developing in Wales, which is world-class, featuring a growing number of exciting and innovative companies. The Optic Centre is relatively a focal point for Wales Photonics. The centre is managed by Glendower University that comprises a number of world-leading academic R&D groups, independent high-tech businesses and business support agencies, together with business events and conferencing facility attracting over 20,000 people per year. Led by project manager Tony Fox-Leonard, the team at Glendower University have met European Southern Observatory's extremely challenging specifications for the European Extremely Large Telescope project. This giant eye in the sky will gather light from distant stars and galaxies, will be 39 meters in diameter, made from 798 segments and located on Mount Ciro's Amazons in Chile. It is set to gather 15 times more light than the largest telescopes around today.
The Optic Centre was developed to bridge between university research and the technology that you've seen being developed in the Technology Centre and business. So we've got business incubation centres here, and we have companies that will come here because we've got specialist facilities, because of our expertise, the expertise of other teams here, and so we will work with them on a commercial basis. We will help them develop processes and to test. We've got very extensive testing facilities for devices and materials, and this will help grow the optoelectronics industry which we have in this area. It'll help to support the existing businesses, and hopefully we'll see more businesses grow from the research which we're carrying out.
It's been an absolute pleasure having the group over here and to show you what we do within our cluster. And as I was saying earlier, the strength of this cluster has been the combination of government with academia and also the private sector from industry. And this goes back about 20 years or so. And what we did is we got together with our government stakeholders and with industrial stakeholders and with the academic stakeholders, and we looked at what the future trends and demands for technology were. So we could see where we needed to fit various gaps, and we decided to make a conscious decision to invest in developing those technologies. And the key thing that's happened is allowed that to happen because we've worked very much in partnership. And over the last 10 years, that partnership has been very successful in supporting a sector that every year has delivered consistent growth. And the sector's grown by about 25% or so over the last 10 years. We are now one of Europe's strongest optoelectronics and photonics sectors, certainly the largest sector of its type and cluster within the UK. The way our Technology Centre works is that we have a one-third funding model. This is quite similar to the funding model which is adopted by the Fraunhofer Institutes within mainland Europe. And what it means is that we have one-third of our funding comes from private sector income. Another third of our funding comes from core government funding, which allows us to build the facility and to reinvest in taking on new staff and taking on new equipment, which has a general usage. And the final third of our funding comes from competitively bid research funding. So we go to research councils, both UK research councils and also European research councils, such as the Framework Programme, now called Horizon 2020, and we bid for funding to run specific projects. So every activity that you've seen here has had money coming in from private sector, from core government money, from our regional government, and also from national governments in terms of project funding.
The project that we're involved in here in Optic is to produce prototype mirrors for the largest ground-based telescope that's ever going to be built. It's going to be built in Chile by the European Southern Observatories. We've been contracted to produce a process that will produce quickly and uniformly very, very high accuracy segmented mirrors. The telescope will need nearly 1,000 of these mirrors over a 7-year build programme and delivery programme. where typical deliveries of this type of component are 26 weeks within the industry. ESO are going to need a build program of one every 1.5 to 2 days. So obviously there's a significant process development there. Glyndŵr have been involved in developing this process over the last 7 years, and we are in a position now where we can produce the mirrors to the correct tolerances, which is the final tolerance of each of these mirrors is 7.5 nanometers RMS. That's an extremely tight tolerance. We can deliver these segments now. We have a repeatable process, and the optical test for this has been developed here at Optic Glyndŵr. This is the only test in the world that has actually met their final specifications and is certified by ESO as suitable for these components.
This is the department where we make the space qualified radiation shielding glass. We make 2 products for the space industry. We make solar cell cover glasses which protect the solar cells of the satellite, and we make optical solar reflectors which are used for thermal control of the satellite. They're made from very, very thin microsheet glass, special glass with thickness ranges from 50 to 500 micron. It's the big thing about the space industry is weight, because as I told you in my presentation earlier, the launch costs are massive, and for every extra kilogram of weight that a satellite has costs about $45,000 in extra launch costs. In the early 70s, when the satellite market was just starting to grow, the British government realised that they needed a presence within the space industry, and they didn't want to be reliant on the American market for providing the glass for space. So they funded the research and development in conjunction with Pilkington Glass to design and develop the glass for space glass. The first space glass was called CMS. It was a soda lime glass, and that was used for about the first 15 years. We then, again in conjunction with the government, developed CMX, which was the replacement for CMS glass. Again, government funding helped us test and qualify that glass, and subsequent glass types we've developed and funded ourselves.